Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. Invent a 3x3 magic matrix using 1 through 9 exactly once, so every row, column, and diagonal adds to 15, with first row 834. Then compute M3 times 111 transpose. After that, we'll jump to a 4x4 magic matrix using 1 through 16 and compute M4 times 1111 transpose. A magic matrix is arranged so every row adds to the same number, every column adds to the same number, and the two diagonals also match that same sum. Here, that magic sum is 15. We're even told a possible first row, 834. And notice it already adds to 15, so it's consistent with the goal. A famous 3x3 arrangement that uses 1 through 9 exactly once and makes all sums match is this matrix. Quick check. Every number from 1 to 9 appears exactly once. Perfect. First, confirm the rows. Each one adds to 15. Now the columns. Again, each totals 15. Finally, both diagonals also hit 15. So this really is a magic matrix. Now we multiply by the all ones vector. Matrix vector multiplication here has a clean interpretation. Each output entry is the dot product of a row with 1, 1, 1, which just adds that row's entries. Because every row sum is 15, every dot product with 1, 1, 1 becomes 15. So, the result is a vector where every component is 15. For a 4 times 4 magic matrix, we don't actually need the full layout to answer the multiplication question. We only need the common row sum. Multiplying by the all ones vector still produces the vector of row sums, so it will be all s's. Add up all entries from 1 to 16 to get the total sum inside the square. Those 136 points are split evenly across 4 rows, so each row must sum to 34. Use the 4-dimensional all ones vector. Each component is the sum of a row, and every row sums to 34, so we get 4 34s. For the 3x3 case, the magic sum is 15, so multiplying by the ones vector returns a vector full of 15s. For the 4x4 case, compute the magic sum from the total. 136 split into 4 equal row sums gives 34, so the product is all 34s. The big takeaway: multiplying any matrix by an all ones vector adds across rows. In a magic matrix, that makes the result a constant vector. Watch the next video to learn more. Next, we'll explore how these all ones vectors connect to special directions of matrix scales in a perfectly consistent way.